What's up everyone, welcome to part 2 of our Mask RCNN tutorial series, and in this one we're going to look at how to set up real-time Mask RCNN. So what you see here is footage from my webcam, and we're running Mask RCNN in real time, and we're able to detect objects like a mouse, pair of scissors, a cup, keyboard, and a cell phone. So in this video I'm going to show you how to set all this up with the previous GitHub repo and openCV. We're not going to get super high frame rates, but I think it's a good start. So let's get into it. So the Mask RCNN GitHub repo we've been using doesn't have a feature to do real-time Mask RCNN. So we're going to have to build that ourselves. And to get an idea of what we need to do, I'm just going to go through this demo notebook just to see how the model is loaded, how the inference is done, how we can get the masks and the bounding boxes and all those things. So I'm just going to scan through it. The first cell is just a bunch of imports specifying where a bunch of directories are, things like that. There is this class called inference config, which just has these two parameters, and we're just going to initialize it. Then if we come down a little further, here's where we load the model itself. So we're going to create this object called model. The mode's going to be inference. We specify a few of these directories and where the config is, and then we just load the weights. So now we have this model that's ready to do inference. So now let's proceed and see how we take those images, get the inferences, and then apply the masks and the bounding boxes. So we've got this list of all the class names, which basically is just to be used to add the labels. And I think this right here, this is all the meat and potatoes of how we're going to need to set up our real-time Mask RCNN. So basically what we're going to do is we're going to read our images. So here, file name is just some image file. And then we're going to get our image. So this is our NumPy array with all the image pixel values. Then what we're going to do is pass image into our model.detect. So the image goes in here and out comes the results. And the results are going to be things like the bounding boxes, the mask, the labels, and the class scores. Finally, what they do is call this function called visualize. So they're going to do visualize.display instances. So they basically have this Python file called visualize and a function called display instances. And what we're doing is we're just passing in our results, and it's going to do all the plotting, and it does it all with matplotlib. So what we're going to need to do is basically write another version of visualize, but instead of using matplotlib, we're going to use openCV. So the main thing here is that a lot of the plotting is all done under the hood within this visualize function. So we're going to have to recreate it ourselves. So now let's look at how we can do that. Now what I'm going to do is jump over to the visualize.py file and take a look at this display instances function. So I've got it open up here in Atom, and now we're just going to scroll through till we find that function. So it's called display instances, and here it is. So we're passing in an image, and then the boxes, mask, class ID, class names, and scores. These are all results from the inference, which we're going to pass in, and then this other stuff is extra things. If we want to, we can specify like the title, the figure size, and if we want to pass a matplotlib axes. So what this thing is going to return is basically a full matplotlib image. So if I scroll down all the way to the bottom, you can see the last thing it's going to do is display an image. And instead of displaying an image, what we want to do is return an image that's got all our masks, all our bounding boxes, all our labels applied to it, so then we can display it in an openCV figure later. So now let's come back up to the top and take a look at the structure of this thing. So we're asserting some things. I'm just going to skip over these ones. We're getting some colors. So there's a function called random colors, which we're going to recreate also, but all it's doing is generating some colors. So it's some tuple of colors, just like we did in the YOLO series. We can basically use the same function as we used in YOLO. So pretty simple function. And moving on, so we've got our colors. We get some parameters from the image, like the height and width. And these are just setting the size and title of the matplotlib axes, which we can skip. But then what we're going to do is loop over all the things that we found in our results. So remember, our results is a list of all the objects we found. We're going to loop over it. We're going to specify a color each time, or a new color. And this is just an if statement, which says, like, if you didn't find a box, or if there's no box in the instant, we're just going to skip it. So continue means skip and go back to the top of the for loop. If we do have a box, it's going to be 4 coordinates, basically top left and bottom right coordinate. So these are the 4 coordinates of it. And then we're going to use some rectangle function that's from matplotlib. So we're going to replace this with the CV2 rectangle function. And we're going to basically use the same thing we did with YOLO. So just apply the rectangle right on top of the image. Next, what we're going to do is apply the label. So the label, we just pick out the class ID, and as long as the score is not none, we're going to use that label. So then we pass in the class ID into our class names list. So this was that big old list that was in the notebook, which was like computer, cell phone, keyboard, all that stuff. So that will give us our label, so it's like readable for us to see what it detects. And then we're just going to create a caption and place that caption right on the image. So instead of using this ax.text, we're going to use the CV2 function called put_text. And then finally, we're going to apply the mask. So there's a function in here called mask, or actually there's a function in here called apply mask. So we're passing in the mask itself, and then we're going to apply it. So let's just take a look at that function, see how it's set up. So I'm just going to scroll up to this function, which is right here. So we're just going to loop over the 3 colors of the image, so R, G, and B. And each time we get to a color, we're using this function MP_where. So it's basically has a condition, and then it's going to be 2 options. So option 1 is if the condition is met. Option 2, if the condition is not met. So if the mask is equal to 1, what we're going to do is take the image and we're going to do this color change to it. Basically apply some color change to it to make it all look like there's a mask on it. And if the condition is not met, we're going to do nothing. We're just going to return the same image there. So again, if the condition is met, then we're going to change the color of the image at that pixel. And if the condition is not met, we're just going to leave the pixel untouched. So that's what this function does. And then we're finally just going to return the image. So now what I've done is created a new blank Python file that's right in the Mask RCNN repository. So here's the file. I called it visualize_cv.py. And what we're going to do is just create or recreate that function to, instead of return the matplotlib image, we're going to return a NumPy image. So let's get started. And of course, we're going to begin with the imports. So we're going to need the following. We're going to need to import this color sys, CV2, and NumPy as MP. So this color sys, we need this thing for, I believe it's for the, and actually, you know what? We don't need this. We're going to do something else. So let's get rid of that. All we need is CV2 and NumPy. So next, what I want to do is create that function that generates the random colors. So I'm just going to call it the same thing, random colors. And it's just going to take in n, and that's it. That's all it's going to take in. And just to make things easier, why don't I go ahead and open up Visualize on the side just so we can see it. So here's the function, random colors, and we pass in how many colors we want. And I'm just going to simplify this function just to make it a little bit simpler. I don't think we need all this extra stuff. So what I'm going to do is, first thing I'm going to do is do np.random.seed. And what seed does is it basically initializes the random number. So when we call it, we get the same one each time. So I'm just going to set this to 1. You can set it to anything you want, but it'll just make sure that the colors are consistent for each frame. So next thing I'm going to do is, it's basically going to be the same line as from the YOLO series, but if you haven't seen that, it's going to be a list, and that list we're going to have a tuple, and within that tuple we're going to call np.random random.rand, and then we'll pass a 3 because we want 3 elements in our random list, and then it's going to be for some parameter we don't care about, in range n, capital N. I'm just going to scoot this over a little more so we can see it. And actually, I'm going to multiply this by 255 just so we get numbers from 0 to 255. And then last thing, all we need to do is return colors. So that function's done. The next one we need is the apply mask. So def apply mask. What we're going to pass in, let's just take a look at it so we can see. We're just going to take in the image, the mask, the color, the alpha, and we're just going to do this for loop. So basically we can just copy it, but I did make some changes to it. So why don't I do the one that I made some changes to? And I'm just going to scoot this over a bit. Cool. So this is the function I did. So for N and C and enumerate color, so we're just going to loop over those 3 colors, those R, G, and B colors. So then it's going to be, we're going to change we're calling out the image, but the particular color channel. So for the first one, we'll do R, and then we apply the mask, and then we apply the mask again for green and blue. But it's the same function we saw, just slightly different, just to make it a little more Pythonic. So this is going to be our apply mask function. Now let's get into the main one, the display instances function. So for this function, I definitely simplified it a lot, got rid of a lot of lines of code because there's no need to make it long. The shorter it is, the better. So I'm just going to scoot this over entirely, and we're just going to call it def display instances. And then what we're going to pass is an image, the boxes, the masks, the IDs, the names, and the scores. Then we'll leave off the doc string for now, but first thing we'll do is we'll create something called n instances, or n instances is equal to boxes dot shape 0. So this is basically how many instances do we have. Nothing too fancy. Actually, I called it n instances. Cool. So next thing we're going to do is just this if statement, which basically, if there's no instances, it's going to do a print statement. And if there are instances, then it's going to do some assertion. So if not n instances, so basically if this thing is 0 or nothing, just say, hey, there's no instances. And if there are, then we're going to assert some things about the shape, the mask shape, and the IDs. Basically just copying this from the original code. So the next thing we're going to do is create the colors. So the colors is going to be equal to random colors, and we're just going to pass n instances. So we want n instance number of colors. All right, next thing we're going to do is define the height and width. So height and width is just going to be shape, and we're going to take the first 2 items in the shape list. Cool. So now we're going to get into the for loop. So let's just bring this up a little bit. So for I, comma color, and enumerate, and we're going to enumerate the colors. So we're looping over all the colors in our random colors list. So the first thing we're going to do is a few statements just to skip if we get bad data. So the first one's going to be if not np.any, and if there's not any boxes, and we're specifying like the loop iteration we're on. So if for the ith one, if there's no boxes, that means there's nothing to display. So what we're going to do is just continue. And what continue means is go back and restart the for loop, go back to the top. So that's the first one. And then we're just going to do that one for now. And the next thing I want to do is we're going to define the boxes. So come back here, and it's going to be y1, x1, y2, x2, and that's going to be equal to boxes for the I iteration of this for loop. So those are our coordinates for our boxes. Then the mask is going to be equal to masks, and it's going to be I. So we're calling out which mask we want from this masks list. Basically just copying from the visualize.py file. So next what we're going to do is create our image, or take our image, and we're going to apply the mask. So what we pass into there, well, it's going to be the image, the mask, and the color. So now this is going to return an image with the mask on it. So after that, next thing we're going to do is add the bounding boxes. So to do that, it's going to be image is equal to cv2 2 dot rectangle, and it should be lowercase rectangle. And what we pass in here is the image. Then we're going to pass the top left, bottom right coordinate. So it's going to be x1, comma y1. Then it's going to be x2, comma y2. Then the next thing is going to be the color, and then the line thickness. So I'm just going to do 2 for now. So now we've added our rectangle. Next thing I want to do is add the label. So for that, it's just going to be image is equal to cv2 dot put text, and I'm going to go to a new line for this, and it's going to be, we pass the image, then we're going to pass what the label is going to be in. Oops, before I do that, I need to create the label. So I'm going to call it caption. It's going to be equal to a string, and the string is going to be 2 things. And the first one's going to be like the text, like is it a book or a cell phone or stuff like that. And the next one's going to be the confidence factor, how confident it is. So some number from 0 to 1. And this one, I'm just going to make it some decimal with 2 decimal place. So then we format it, and the first one's going to be the label, and the second one's going to be the score. And if the score, else label. So now we need to, shoot, I forgot to create the label. So real quick, the label. So the label we're going to take from the names. We're going to pass in the IDs, and which ID it's going to be. It's going to be the ith one. So this is going to return like the dinner table, the cell phone, the cup, stuff like that. So that's what the text is here. And then the scores, I forgot to get those as well, but this is just straight from the GitHub repo as well. So the scores is going to be scores.I if scores is not none, else none. So now we can just add these to our caption. So we're going to back to our put text command. It's going to be image caption, then the location of it, and it's going to go in the top left corner. So x1, y1. Then we specify the font. So it's this font Hershey complex. And now we specify the size. So I'm going to go with 0.7. The color is going to be color, and then the line thickness is going to be 2. So now we've got an image with a mask, with a bounding box, and with the label. So now let's just come out of the for loop and return the image. And let's just check our work again. So we are going to loop over all the colors, and the number of colors is equal to the number of instances we have. So for each instance, we're going to get a box, we're going to get a mask, we're going to get a label and a score, and we're going to apply a mask, then we're going to apply a box, and then we're going to add a caption, and finally we're just going to return the image once we've looped over it enough times. So now let's test this. Let's run it with our webcam and see what we get. So the first thing we need to do, or actually in order to test this, what I'm going to do is just come down here and do if name is equal to main. We're going to put everything in here just to test it. And the reason why we do this is because this if name equals main part, this only gets run if we run the file directly. If we import this file, it's not going to run, so it's safe to put it down here if we want to use this thing later. So we need to import a bunch of stuff. These are just imports from the demo.py file, so I'm just going to go ahead and paste them in here. So os, sys, random, math. We already imported numpy, so no need to do that. And we don't really need this either. So yeah, we're going to import all this stuff. And actually we don't even need that one as well. So now let's go ahead and define all those directory paths. So things like root dir, model dir, Cocoa model path, all of these are taken directly from the demo.py or the demo notebook. So we've created those, and then we're basically just taking stuff directly from that demo file. So if not os.path exists, so if the Cocoa model path doesn't exist, we're going to download the trained weights, but we already have them, so it's not necessary. And now let's create the class, the inference class. So this class inference config, we're going to pass in this cocoa.config. We pass 2 parameters. Then we're going to initialize it to config, and then we'll display it. Again, just copying directly from the notebook. So now let's initialize the model. So model is going to be model lib, mask RCNN, mode is inference, model dir is model dir, config is config, and finally we'll load the weights. Now let's create our class names list. So this is that big old list of all the things we're going to be able to detect. So person, bicycle, train, all this stuff. So just a big long list of names. And then now we're going to get into the new stuff. So we're going to initialize our capture device. So I'm just going to add that right here. So our capture device is cv2.video capture. We pass a 0 because if you have a webcam, it's always going to be the 0, 1. Then I'm just going to expand the size to be 1920 by 1080, so it takes up the whole frame. If you don't have a camera with that resolution, you can always just leave these 2 lines off, but I'm going to increase it just so it takes up more of the frame. Next, we're going to get into the while loop, and we're basically just copying stuff from the YOLO series. So while true, we are going to call ret, frame, and that's going to be equal to our capture device dot read. So we get our frame, and if we're not capturing, this will turn false. Next thing we're going to do is we're going to get our results. So we're going to pass in our frame into our model. So we pass in the frame and we get our results, and the results are all that stuff, the mask, the boxes, the labels, all those things. Then what we have to do is we just need to strip off one thing from it. So they called it R in the notebook, and R is going to be results, and it's just going to be the first thing in the results list. So now what we're going to do is call frame is equal to, and we're going to call our function display instances, and what we're going to pass is the image, or excuse me, the frame. Then it's going to be R comma ROIs, then it's going to be R masks, oops, then R class IDs, then it's going to be these class names that we created, then it's going to be R scores. Again, all of this is from the demo notebook. So now what we get returned from our display instances is a frame, but with all that stuff, the mask, the box, the label. So all we need to do is display this in a window. So in order to display it, it's going to be cv2.imshow. What we're going to show is, well, we're going to call the frame, and we're going to display the frame. Finally, we just need our break command. So if we want to stop streaming, we do cv2.waitKeys1 and 0xff is equal to ORD Q, which means if you hit the Q button, it's going to kill the window. Finally, once we're done with that and we've broken out of our while loop, we're going to do capture.release and cv2.destroy all windows. So this should be it. And I'm going to go ahead and run this, but first I'm going to stop my screen recording and then pick back up once I'm got the model running, because again, the screen recording takes up some GPU resources, which blocks the model from running. So we'll be right back, and if everything works, we should be seeing the Mask RCNN in real time. Look at that, first time. So here it is running again. You can see we're detecting all the same stuff, but we've got this big label for dining table that's right across everything. So what I had done before is added an if statement. So if the confidence factor was like under 0.8, I would skip it. And I'd also remove the dining table since it's taking up everything. But this is basically it. We're getting our real-time algorithm, our real-time Mask RCNN running. So we're not getting super high frame rate. This is about 1.5 to 1.8 frames per second, which is pretty low. But at the same time, the Facebook group that created Mask RCNN, they were reporting 5 frames per second using Cafe2, and I think a lot better GPU than me. So about 2 frames per second, that's not too bad. Maybe we can eke out a little bit more performance by skipping some steps, but that's what we've got working with now. So in the next video, what we're going to try and do is maybe get a little bit more performance out of it. And yeah, I'm not sure what else we're going to do with Mask RCNN. If you've got any ideas, leave them in the comments below. But yeah, so that's going to do it for this video. I know we went through the code kind of fast, but I'll be posting this file to my GitHub so you can refer to it. If you've got any questions, leave them below. I'll be more than happy to try and help you guys out, see if we can get this running. But if you like the video, leave a like. And if you like the content you're seeing, then hit the subscribe button. And I'll see you guys in the next one. Peace.